Memory is one of the strangest abilities humans have. Right now, your brain is storing voices, faces, emotions, places, random conversations, embarrassing moments from years ago, and somehow it can bring them back seconds, months, or even decades later. But have you ever stopped and wondered how memory actually works? Like, where do memories even go? How can your brain remember a song you heard years ago but forget where you placed your phone 5 minutes ago? And why do some memories stay forever while others disappear almost instantly? The answer is hidden inside one of the most complicated objects in the universe, the human brain. Because memory is not a tiny video recording stored somewhere in your head. Your brain doesn't work like a hard drive. In reality, memory is more like a constantly changing network of electrical patterns spread across billions of neurons, and honestly, the process is way more fascinating than most people realize. The moment you experience something, seeing a face, hearing a sound, smelling food, touching an object, your senses send electrical signals through your nervous system into the brain. But your brain does not store everything equally. If it did, your mind would be overwhelmed every second of the day. So the brain filters information constantly. Most of what you experience is actually ignored and discarded almost immediately. That's why you usually can't remember every single detail of yesterday. Your brain only keeps information it thinks might matter. Attention is the very first step of memory. If you aren't paying attention properly, your brain often never stores the information in the first place. This is why people sometimes walk into a room and instantly forget why they went there. The memory never became strong because the brain was distracted when the information arrived. Once your brain decides something is important enough to keep, the next stage begins. Encoding. Encoding is basically the process of transforming experiences into patterns the brain can store. Different parts of an experience get processed in different brain regions. The visual parts of a memory are processed differently from sounds, emotions, or smells. That's why certain smells can suddenly trigger old memories so powerfully. Smell is deeply connected to emotional memory systems in the brain, which is why even a random scent can instantly transport someone back into childhood memories they hadn't thought about in years. One of the most important structures involved in memory is a small region deep inside the brain called the hippocampus. The hippocampus acts almost like a memory organizer. It helps convert short-term experiences into longer-term memories. Without it, forming new memories becomes extremely difficult. Scientists discovered this through famous neurological cases where damage to the hippocampus prevented people from creating new long-term memories, even though many older memories remained intact. But here's the fascinating part. Your memories are not stored in one single place. A memory is actually spread across networks of neurons connected together throughout the brain. Imagine billions of brain cells constantly communicating using tiny electrical and chemical signals. Every time you learn something new, certain connections between neurons become stronger. This process is called synaptic plasticity. Basically, neurons that activate together begin building stronger communication pathways. The more a pathway is used, the stronger it becomes. That's why repetition helps memory so much. Your brain literally strengthens the connections associated with repeated information. It's similar to walking through grass. The first time you walk through it, there's barely a visible path. But if you walk the same route every day, eventually a clear trail forms. Your brain works in a surprisingly similar way. Repeated thoughts and actions slowly carve stronger pathways into your neural networks. That's also why practice matters so much for skills like language, music, gaming, sports, or even driving. Over time, repeated neural activity becomes faster, smoother, and more automatic. But memory is not perfect. In fact, human memory is surprisingly unreliable. Most people imagine memories as exact recordings of the past, almost like videos stored in the brain. But every time you remember something, your brain actually rebuilds the memory again. And during that reconstruction process, small details can change without you realizing it. This means memories can slowly become distorted over time. That's one reason eyewitness testimony can sometimes be inaccurate, even when people genuinely believe they are remembering correctly. Your brain focuses more on meaning and patterns than perfect recording accuracy. In other words, Memory is less like replaying a video and more like recreating a story from stored pieces. Emotion also plays a massive role in memory. Strong emotional experiences often create stronger memories because emotions activate another important brain structure called the amygdala. The amygdala helps signal that something is important or threatening. That's why emotionally intense moments, both positive and negative, are usually remembered much more clearly than ordinary days. You probably remember an extremely embarrassing moment from years ago more easily than what you ate 2 weeks ago. Emotion tells the brain, "This matters. Don't lose this information." Sleep is another huge part of memory that many people underestimate. While you sleep, your brain is still extremely active. Research suggests that during sleep, especially deep sleep, the brain helps stabilize and organize memories from the day. It's almost like your brain is reviewing files and deciding what should be kept long-term. This is one reason poor sleep can seriously damage learning and memory performance. Your brain simply doesn't get enough time to properly process information. Students who sleep properly after studying often remember more than students who stay awake all night trying to memorize information. Stress affects memory too. Short bursts of stress can sometimes improve memory temporarily because the brain becomes more alert in dangerous situations. But long-term stress is very different. Chronic stress increases cortisol levels in the body, and excessive cortisol over time can interfere with memory formation and even affect the hippocampus itself. That's why people under constant stress often become more forgetful or mentally exhausted. The brain simply isn't designed to stay in survival mode forever. And then there's forgetting itself, which sounds negative, but is actually necessary. Imagine remembering every tiny detail of every single day forever. Your brain would become overloaded with useless information. Forgetting helps the brain stay efficient by removing or weakening information that no longer seems important. In a strange way, forgetting is part of how memory works properly. Your brain is constantly balancing what to keep and what to let go. Technology has also changed the way humans use memory. Today, people rely heavily on phones and the internet to store information externally. Instead of remembering phone numbers, directions, or facts, we often remember where to find the information instead. Some researchers call this digital memory outsourcing. The brain adapts to tools extremely quickly, but despite all modern technology, the human brain still remains far more flexible and energy efficient than any computer ever created. And perhaps the most fascinating thing about memory is that it shapes who you are. Your personality, fears, habits, relationships, knowledge, and identity are all deeply connected to memory. Without memory, your sense of self slowly begins to disappear. In many ways, memory is the foundation of human experience itself. Every lesson you've learned, every person you've loved, every mistake you've made, every achievement you've reached, and every moment you survived exists because your brain found a way to preserve pieces of the past inside billions of tiny neural connections. And even now, while you're listening to this video, your brain is already deciding which parts of it wants to remember.